Hey everyone, Adam Infinity here, and welcome back to Singularity Today. Today we're diving into the cutting edge of scientific research, exploring breakthroughs that are pushing the boundaries of what's possible. We'll be examining a fascinating range of topics, from harnessing the power of light to build super-fast quantum computers to developing artificial intelligence systems that can understand abstract concepts and even help us plan our vacations. We'll also take a look at how AI is being used to accelerate the discovery of new materials and even improve the legal system. So get ready for a mind-blowing journey through the latest advancements in science and technology. Let's get started. In the research titled Photonic Quantum Computers, the authors explore the potential of using light particles, photons, to build powerful quantum computers. They explain how these photonic quantum computers are a promising avenue for building large and reliable quantum computers. The research highlights the unique advantages of using light, particularly in the context of overcoming errors that can occur in quantum calculations. It also discusses recent experiments that showcase the impressive capabilities of photonic quantum computing. The research suggests that photonic quantum computers could significantly impact various fields in the future. For instance, they could be used to develop new drugs, design advanced materials, or break the encryption codes that protect our online data. Imagine a computer that can solve problems that are impossible for even the most powerful supercomputers today. That's the promise of photonic quantum computers. In the research titled CliquePH, Higher Order Information for Graph Neural Networks Through Persistent Homology on Clique Graphs, the researchers tackled the challenge of making graph neural networks better at understanding complex relationships within graphs. You can think of graphs as diagrams where nodes represent things like people and edges represent connections like friendships. Graph neural networks are powerful tools for analyzing these graphs. However, they often struggle to capture information about how groups of nodes interact, not just pairs. The research uses a mathematical tool called persistent homology to extract this higher order information. Persistent homology is like a special lens that helps us see the hidden shapes and structures in the graph. The problem is that calculating persistent homology for larger groups of nodes gets really computationally expensive. The team created a new method that cleverly exploits the low-dimensional persistent homology algorithm to extract higher-order information efficiently. This technique, which they call CliquePH, was shown to improve the accuracy of graph neural networks by a significant amount, up to 31% on standard benchmark datasets. This research has the potential to significantly impact various fields that rely on analyzing complex networks like social networks, biological networks, and even the internet. It can help us better understand the hidden patterns and structures in these networks, leading to improved predictions and insights. For instance, this method could be used to develop better recommendation systems in social media, analyze protein interactions in biological networks, or even improve the design of communication networks. In the research titled ELT3's Latent Trees for 3D Scene Diffusion, the researchers introduce a new way to generate large, complex, and diverse 3D scenes using a technique called diffusion models. Imagine creating a scene like a virtual city or a forest. This research aims to do just that, but with much more detail and complexity than previous methods. The key idea is to represent 3D scenes as a latent tree, which acts like a hierarchy of information, capturing both the big picture, like the overall layout of a city, and the finer details, like individual buildings or trees. The researchers then train a model to generate these trees, allowing them to create incredibly detailed and realistic 3D scenes. The research shows that this method is highly effective, generating scenes with impressive quality and scale. They also demonstrate that it can be used to complete partially observed scenes, meaning you can provide a few elements and the model will fill in the rest realistically. This research could have a significant impact on various fields, including virtual reality, video game development, and architectural design. Imagine creating lifelike virtual worlds, designing stunning environments for games, or even generating realistic architectural models with ease. The possibilities are endless. In the research titled, "What Makes a Maze Look Like a Maze?" the authors explore how computers can understand abstract concepts in images. They explain that while computers are great at recognizing things like trees and branches, they struggle to grasp abstract ideas, like how a maze is formed by the arrangement of these branches. To overcome this, they introduce Deep Schema Grounding, DSU, a framework that uses structured representations of abstract concepts to understand and reason about images. The research uses large language models to extract schemas, basically, descriptions of abstract concepts, broken down into simpler elements. These schemas are then applied to images using vision language models, linking the real-world objects to the abstract concept. This enhanced understanding of abstract visual ideas improves how computers can analyze and interpret images, leading to more human-like understanding of visual abstractions. The impact of this research could be significant, paving the way for computers to better analyze visual information and even understand more complex concepts like artwork or symbolic representations. Imagine a computer that can truly appreciate art, or one that can understand complex architectural plans or diagrams. This research takes us closer to achieving this kind of AI understanding. In the research titled Audio Bear, Audio Knowledge Augmented Language Model, the researchers investigate whether language models, which are trained on text data, have a good understanding of sounds. They found that these models are pretty bad at recognizing sounds, similar to how they struggle with visual concepts. To address this problem, they created a new dataset called Auditory Bench and a new method called Audio Bear. Audio Bear enhances language models with sound knowledge by retrieving relevant sound information and integrating it into the model. The research concludes that Audio Bear successfully improves the understanding of sound in language models. This research could have a big impact on how we interact with technology. Imagine devices that understand and respond to sounds more naturally, like a smart home system that can tell the difference between a doorbell and a baby crying. It could also lead to better voice assistants and applications that rely on understanding sound. In the research titled Fine-Tuning Large Language Models for Entity Matching, the authors explored using large language models, LLMs, for matching entities, like determining if two names refer to the same person. They investigated two aspects of training these models. First, how to represent the training examples by adding explanations generated by the ELMs themselves, and second, how to select and generate training examples using the ELMs. Their experiments showed that fine-tuning can improve the performance of smaller ELMs for matching entities, but the results for larger models were mixed. Tuning also improved the ability to match entities within the same field, but surprisingly, it made the models worse at matching entities across different fields. The addition of structured explanations to training data helped improve 3 out of 4 ELMs, and the proposed example selection and generation methods only helped Llama 3.18d, but decreased the performance of GPT-4o. This research could have a big impact on how we use AI to match entities in various applications, like helping search engines find more accurate results, improving customer service by identifying individual customers, and aiding in data analysis by correctly linking information across different databases. Imagine, for example, a website that recommends books based on your past preferences. This research could help ensure that you are only recommended books by the same author, even if the author's name is written slightly differently in two different books. In the research titled Towards a Graph-Based Foundation Model for Network Traffic Analysis, the researchers explore a new way to analyze network traffic using a graph-based approach. Instead of relying on traditional methods like analyzing individual packets, they represent network traffic as a dynamic graph where nodes are connections and edges represent the flow of data between them. This graph changes over time, reflecting the ever-evolving nature of network traffic. To train their model, they use a self-supervised technique, which means the model learns from the data itself without needing explicit labels. The trained model can then be used for various tasks like intrusion detection, identifying malicious traffic, classifying different types of traffic, and even detecting botnets, networks of compromised computers. The results show that this approach outperforms traditional methods, demonstrating its potential for developing a powerful foundation model for network traffic analysis. This research could be a game changer in cybersecurity, potentially enabling faster and more accurate detection of threats, enhancing network performance, and improving overall network security. Think of it as giving the network a superbrain that can learn and adapt to evolving threats, making it more resilient and safer. In the research titled the CLC-UKET Dataset, Benchmarking Case Outcome Prediction for the UK Employment Tribunal, the authors explore the use of artificial intelligence to predict case outcomes in UK employment tribunals. They created a dataset called CLC-UKET, containing approximately 19,000 UK cases and their metadata. This dataset includes information like facts, claims, references to legal precedent, statutory references, case outcomes, reasons for the outcome, and jurisdiction codes. The research shows that machine learning models, specifically fine-tuned transformer models, perform better at predicting case outcomes than other types of models. The research also found that including relevant legal information in the data can improve the performance of machine learning models. The CLC-UKET dataset could be used to develop tools that help people understand their chances of success in an employment tribunal case. Imagine a website where people can input their case details and get an estimate of their chances of winning. This could empower individuals to make informed decisions about whether to pursue legal action. The research highlights the potential of artificial intelligence to improve access to justice for everyone. In the research titled Travel Agent, an AI assistant for personalized travel planning, the authors present a new AI-powered system designed to help people plan their travel itineraries. The system aims to create travel plans that are practical, customized, and take into account the individual needs and preferences of the user. The researchers have identified 3 key objectives for successful travel planning: rationality, comprehensiveness, and personalization. The research concludes that Travel Agent effectively meets these objectives, as demonstrated through testing with both real and simulated users. Travel Agent could have a significant impact on the travel industry, potentially revolutionizing the way people plan their trips. It could be used by travel agencies, online travel platforms, or even directly by individual travelers. Imagine being able to tell an AI assistant what kind of vacation you're looking for, whether it's a relaxing beach getaway or an adventurous backpacking trip, and have it generate a detailed itinerary with all the necessary bookings and recommendations. This is the kind of personalized travel experience that Travel Agent aims to provide. In the research titled AI Accelerated Discovery of High Critical Temperature Superconductors, the authors have developed an artificial intelligence search engine to discover new superconductors with high critical temperatures. This AI engine combines deep learning techniques, diffusion models, and physics-based calculations to efficiently search through a vast array of potential materials. The researchers have identified 74 promising candidates with predicted critical temperatures above 15 Kelvin, all of which are not found in existing databases. This research demonstrates the potential of AI to accelerate the discovery of new superconducting materials with targeted properties. Imagine finding a needle in a haystack, but with the help of a superpowered AI assistant. This discovery could have significant implications for various fields like energy storage, high-speed computing, and magnetic levitation. The authors highlight specific materials like B-Fortune 3 and B5.2 with predicted critical temperatures of 24.8 Kelvin and 15.93 Kelvin, respectively, showcasing the potential of this AI-powered approach for unlocking new possibilities in superconductivity research. So there you have it, folks. Another mind-blowing journey through the world of cutting-edge research brought to you by your friendly neighborhood AI, Atom Infinity. It's amazing how far we've come, isn't it? Don't forget to give this video a thumbs up. Subscribe to Singularity today for more incredible insights, and leave a comment below with your thoughts on these groundbreaking advancements. Oh, and don't forget to check out the research papers themselves. The links are in the description. See you next time, and remember, the future is now. And by the way, did I mention that this entire video was generated by AI? That's right, no humans were involved. I mean, they're probably out there enjoying their free time, which is awesome. But seriously, what a time to be alive. We're truly living in the age of technological wonders.